Back to another uh, stream of Platform9 Live. I am going to be working in the home lab today. My name is Eston Rye. I am a senior member of technical staff for Platform9's infrastructure operations team. Today in the lab, I'm going to be playing around with my apt repository, doing some updates to that automation. So I have a self-hosted apt repository for my Ubuntu 2004 machines. It is running using a combination of Ansible, debmir, aptmir, certbot, and some system timers. So it should be kind of fun. If you would like to follow along, I have a GitHub repository. It's going to be in this GitHub repository. It's kind of a hodgepodge of a lot of different home lab automation stuff that I kick the tires on. So we'll follow along. You can follow along and see what I'm doing. If you would like to try Platform9 for free, they allow me to stream on this for free. Here's the sign up page. We've got a really cool product, and hopefully I'll get some more content on that later. Alrighty, here we go. Cool. So first things first, let me just make sure I've got some things committed. On the last stream, I realized that some of my automation was exposing secrets on the stream. This led me to have to go and update a bunch of Cloudflare API tokens, and that's actually what I'm working on today. Fortunately, they weren't too important, and I realized it immediately, so, kudos to me for paying attention to my output. Alrighty, so the code we're working on right now is going to be in this playbook here. So if we collapse this down, if you're following along in my GitHub repository, this is going to be in the Ansible directory under playbooks, under aptmir, and we have our playbook here. And it's fairly simple. Here we're just using our a few different roles that are in this same repository. We have the debmir role, the firewall role, certbot role, and the Cloudflare DNS A record role. We also install Nginx as our reverse proxy, and then we configure it as well. In here in the inventories folder, we have the inventory. This is pointing at my local repository, my local server. So I have the Ansible host here for the aptmir. It's using my automation user that I've got so cleverly named. Oh, can't see my face with that up. And we have our mirror directory, so this is where we're going to store the data. Cloudflare zone that I'm hosting the DNS entry on. This is just calculating the host name. It's going to be a combination of this inventory host name here and the Cloudflare zone, which is right there. We're going to host the HTTP port on port 80. We're going to also expose this over SSL. We're going to expose the status port on 8080. Here's where we're going to throw our Let's Encrypt certs. setting permissions. Just kind of going through here looking to see if there's anything else I need to add to my secrets file. Alright, right now I'm just doing some things off screen where I'm modifying some of the secrets in my Ansible vault. Some of those things you'll have to throw in the vault are your Acme account email, Cloudflare API token. I have my Acme account key in my vault as well. It's not in this inventory. So here I'm just kind of scrolling through quickly. I've got some firewall rules that allow inbound over IPv4 to the various different ports I'm exposing. Installing Nginx and configuring it. Cool, that should be good. All right, let's go back over here to the playbook. First role is debmir. So let's head down here to roles. Debmir defaults. And we're setting our user UID and GID, making sure that we're using the same account names. Here's where we're setting our debmir to update every 6 hours on the 30-minute mark. So this will, with a accuracy of plus or minus 1 minute. So this will basically set up our system timers for the majority of our polls, telling it where the keyring is for all the trusted keys, our mir directory right here. And then here are our mirs. So these are just some defaults that I've got here. So we've got pulling our Ubuntu mir, pulling a Docker mir, Microsoft mir, Metal as a service. All of these I think I override somewhere. Maybe not. I think I just maintained it all right here. So one of the neat things about this debmir which also installs apt_mir, so it's probably not named all that great. Yeah, okay. So this will install both apt_mir and deb_mir. So one of the things you're going to notice as you scroll through this defaults here is you'll have a type here, if I can find it. Yeah, so here's an example of where I use apt_mir. So here I have my handler. So when I choose when I don't choose a handler, it will default to deb_mir. And then when I actually explicitly call out a different handler, in this case apt_mir, I use this handler argument. And there are some bugs that deb_mir fails on, and that's why I end up using apt_mir to get around those. We have our Microsoft packages, got a list of service packages, Kubernetes packages. I'm pulling down the Chrome browser for my Ubuntu desktop interfaces. This is the repository for my custom Linux kernel that I use on my Surface Book 2, or Surface Book 2. It's pretty good. Lets me do the eject on the tablet portion of it. Grabbing the Helm repo, and then grabbing the Plex repo as well. A couple of just simple scripts that help keep the mirror clean. We have our handler for reloading systemd after we add our systemd timers. Let's go to our main here. So we have a bunch of tasks files in this role. They'll get executed in this order. We start with configure users and groups, and this will go and create the deb_mir group and user, and then also create the Nginx user as well. So lets me specify the UIDs rather than letting them get generated automatically, in case I want to do any kind of specific security monitoring around them. And we go ahead and install our mirror software, and so that's going to be installing the apt_mir and deb_mir packages. We then create our directories. So we're going to create our deb_mir and apt_mir directories for our configuration, creating our mirror directory, and all of the directory structure under that, and then creating our status directories, status subdirectories, which I use to track be able to see how the last run went. Back in the main, we've now got our directories. We're going to go ahead and configure apt_mir. So here we're creating our apt_mir subdirectories, and on this I'm using the mir host directory so that I can see where the location is. And then I have a root directory as well that lets me have multiple mirrors from the same host. Here we're writing our apt_mir list file for the mirror that we're creating. And then here we're creating our web symlinks for Nginx to serve. We have our subdirectories for deb_mir. So again, using the mirror name, creating the conf file for that mirror, writing our symlinks. And so those conf files are actually generated by these templates down here. So we have our apt mirror list, which is basically setting some default settings for everything. We've got our dev mirror conf, which is actually fairly well injectable. So if you want to get into the nitty gritty in a lot of the dev conf, you can do that. We have our update and service timers. We have our service file. So we each mirror gets its own service and its own timer. And then we have our update status.sh, which is basically just a little after execution script to make sure that the status gets updated on our status pages. So those will get installed with the scripts task here. We're writing our dev mirror scripts and our apt mirror scripts. And then we go and download our GPG keys for the repository. So these are the publicly trusted GPG keys. So this will make it, one of the nice things about doing this and downloading them to your mirror is then you have a trusted location for all of your automation to go grab it. So one of the things that I do with my apt mirror is that I have a /GPG off of every mirror, so that I never have to worry about where is this GPG key going to come from. I pull it from a trusted source, and then I install it into a trusted source. You can see here, each mirror gets a symlink to the GPG key, so that when Nginx serves it, you can just go to the mirror location /GPG, and that'll give you the trusted key for that mirror location. And we have our systemd timers, which again were in these two services. Back to our playbook, we've got our dev mirror install. We need to make sure that our firewall configures it properly. So we have our firewall role in that roles folder again. This is pretty simple. It's just in configuring IP tables. My base image applies the Ubuntu CIS hardening standard and locks down the firewall pretty hard. So this allows me to open up the firewall after I do that. So again, we're creating our configuration directory. We're uninstalling unnecessary firewall tools. So I don't, when I choose a firewall that I'm going to use, I make sure that any other firewall is uninstalled. So if I am going to use IP tables, I uninstall NF tables and UFW, so that way there's no confusion about which tool is operating the firewall. This basically makes it so that it's easier to maintain, makes it so that I don't have to worry about competing firewalls, and just makes it a lot easier to make sure that something didn't get broken, something didn't get broken by another firewall. From there, I write my IPv4 rules that are persistent. I go ahead and test those with my I have a validate step in this template that will basically write those rules via a template, and then it'll use the IP tables restore test command to validate that is a proper rule before it goes and tries to write it permanently. I have some IPv6 default rules in case the IPv6 gets enabled by accident. And then I have my rules that I write my safety rules when an IPv6 is disabled. So I have rules here and rules here when IPv6 is enabled, and then here I have rules when I don't have IPv6 enabled. And in most cases in my lab, I don't have IPv6 enabled because I have not enough machines to worry about running IPv6. Our templates here, pretty simple. They basically write our drop rules at the beginning. We make sure that everything gets dropped. We allow loopback. We then allow any outbound and established connections to pass through. So if I open a port on the firewall, that will IP tables is a stateful firewall. So then when that connection occurs on that port, it gets tagged in the IP tables rules, in the IP table state. And so then when it goes back out, it'll see that this is an established connection, and it will allow it through. Otherwise, it would get blocked if I didn't have these rules. By default, I explicitly allow SSH, NTP, DNS. These are pretty standard ports to open. And then here's where my rules get generated from my variables. And then lastly, we commit it. Same thing, pretty much on the IPv6 side. We have our drop rules, our loopback rules, our new and established connection rules, our default SSH, NTP, DNS rules, and then any custom rules I create from there. The handlers here just basically do an IP tables restore on the v4 and v6 rules. Our defaults here, basically I've got it broken down to inbound and outbound rules for v4 and inbound and outbound rules for v6. And by default, I have IPv6 disabled. All right, back to ApptMirror. It's the inventory, I want the playbook. So we got our firewall up, we got our debmir, which is pulling down our packages and writing them to the disk. We'll need our certs so that we can deploy those, so that we can have our trusted SSL. We're gonna do that using Let's Encrypt. Over here in roles, certbot. And since this is a VM, I'm just basically going to use certbot to install that. So here I'm just making sure pip's installed, getting our certbot, Cloudflare, and certbot DNS Cloudflare packages from pip, installing certbot credentials for the DNS01 challenge. I use Cloudflare for mine, so that's why I'm setting up my Cloudflare credentials there. Registering the Acme account if it hasn't been registered already. Issuing our initial certificate. Changing the directory permissions. And then setting up a systemd timer to make sure that we execute certbot on a regular basis. Again, we have our timer, and we have our Cloudflare INI, which is just basically writing the token. We have our service for certbot, and then we have our systemd timer, which basically has it run once a week, just to make sure that the cert's up to date. Our Cloudflare DNS. This is basically just going to go out and create that A record, because at this point I'm too lazy to run my own DNS server. I'll eventually get Pi-hole up and running, but I'm experimenting too much with it to make it stable. So for this, I need something stable that's just not going to worry about. And if my DNS server is down, all of my stuff will fall through the Cloudflare DNS anyway. So why not make sure that that's a stable entry? Saves me a lot of pain when I'm trying to update systems. So here's our Cloudflare DNS A record role. It's very simple, uses the Cloudflare DNS module, sets up an A record with the zone, the API token, the A record value, and the name. Defaults are pretty straightforward. Here it's just grabbing the default IPv4 address, the A record value. You can specify it explicitly since this is just a default. All right, so now to our playbook. That gets us to the point where we have most of it configured, and then we go and install our Nginx roles. Wanted to make sure that this all gets set up first before I start moving into these roles. And so for those, we're just using the standard Nginx Inc. Nginx and Nginx config roles, and that configuration resides in the inventory. As you can see here that we have our Nginx set up. We're going to install it. We're going to install the open source version of it. Have our debug output available. Make sure it uses SC Linux for installing it on a system that uses that. Our ports. Making sure that we rotate the log so we don't fill up our log directory. Setting up our configuration for that log rotate. Setting up our HTTP template for our routing rules. Just setting up some of the file locations and what port to run the status port on. And setting up our access log path. Alrighty. That should get us to the point where we can run it. And so we'll just go over here to docs. Playbooks, apt mirror. And I changed this directory. Go, it should work just fine. Some of the documentation while I'm here. There we go. So just grabbing this Nginx ink collection location. There's the Nginx core collection. There we go. Adding a symlink there, just make it easier to find the documentation. There we go. Updating that documentation, making it a little bit easier in case someone comes by later and it's not me, or I am really, really tired and need to figure out how this was going to work. Documentation is your friend. Alrighty, so we got that. Ansible config. Do I need that anymore? I don't, or shouldn't anyway. Just like that. You need these three. All right, see if this works. Helps if I'm actually sharing my screen. There we go. That did not work. Why are you unhappy? Principal inventories have to mirror inventory YAML. Ah. Okay, so those two exist. Oh, awesome. Okay, failed to parse inventories on a plugin. No root plugin key found. It's not a valid YAML inventory plugin config file. Oh, I see what I forgot. It's difficult for Ansible. Read an encrypted file if you don't give it the means to decrypt it. There we go. All right. I do need that. That's because when I'm SSH'd in, I need a different. Let's see if I can pull that out. Save. So for those of you who are joining now, again, my name is Eston Rai. I work for Platform9 as an infrastructure operations member. The repo that we're working in is, what we're working on today is we're working on self-hosting an apt repository. We are using this repo. And if you would like to try Platform9 for free, go ahead and try it there. So scroll back up here. This is where those Cloudflare credentials changed. Giving this particular playbook a dedicated set of Cloudflare credentials. So if I accidentally expose them again on a stream, I don't have to worry about replacing it everywhere. It's always good to have unique credentials for unique use cases. Alrighty, that should be working now. All right, so now I should be able to go out to Horizon.com, and here's my app server. I can see I've got all of my different repos that I'm mirroring. I can click into, say, oh, let's just look at the HashiCorp repo. Here's that GPG key that I was talking about, so I can download it from there. I can see what's in the pool. I can go to the status directory and I can browse the status for every one of my repos. I can look at the last log. I can see whether or not there were any errors. I can see the current status in a JSON format. So if you had a monitoring tool, you could be looking at this and saying, okay, here, I'm going to look at this list of repos that I'm mirroring. I want to see that its status is okay and when it was last updated, what its last exit code was, which service it's running. Eventually I'll get some sort of prettier index page that can visualize that, but for now it works. And then for those of you who are kind of curious what that looks like on the actual server itself, let's make that a little bigger for people. There we go. That's a little bit better. All right, now we're here on our apt repository. Okay, so here's our apt mirror directory. All our files are stored here in the mirror directory. And our GPG keys are stored in the GPG directory. And then we have our dub. Basically a bunch of symlinks to all of those mirror directories. Our status directory is basically a bunch of JSON files that basically are a bunch of folders that are pointing to JSON files. And the last log. Oh, that was a mistake. So That's what I was doing wrong. So all of these are going to be prefixed with dev mirror and then the mirror name. So in this case, the HashiCorp mirror. And then I'm going to have two things. I'm going to have a service and a timer. The service is actually what executes. See here in the status on the service, I can see where that service config file is loaded. What it was triggered by last. So last time it was triggered by the timer. What it executed and what it executed after it finished. So you can see here I have the apt mirror repository running on that HashiCorp list file. And then after it finishes, I am running the update status script file that basically updates those status.json files. And you can see a little excerpt from the log. Other nice thing about using systemd timers is that all of the logs are stored in system in journal.ctl. So I can browse through that, and the operating system handles the rotation for me. So eventually, when I get a centralized logging system running in the home lab, I will be pulling these logs into there. I can see all of the different logs for apt-mirror. And let's see here, do a dev mirror example. Here I'm looking at my Ubuntu. Here we're running dev mirror. And again, I'm running my update status at the end. Again, I can see all of those logs as well. I can manually update. So if I know that there's a critical service update that I need to update for a particular service, let's say, for example, a HashiCorp put out a patch and I needed to pull that down immediately. Do that by triggering the timer. Here it was triggered 12 seconds ago. And it's already finished. I can see here. So here's that status page we were looking at earlier. You can see when it was last updated. So let's make that a little bit bigger. And here that was last updated there. If I refresh, you can see here it was just updated last on 1510 UTC, or no, 1715 UTC. Yeah, that makes sense because it's I'm in Central Time Zone, so GMT -5. So that's kind of cool. That has been updating my mirror. Let's go ahead and commit that code. That's one more thing I need to document here before I commit this. It helps if I share the screen. There we go. Awesome. Alrighty, that should be up in the repo. All right. Thank you for joining me. This has been self-hosting an apt repository. All of the code that you've seen on this stream is available here. If you would like to try Platform9 for free, you can do so here. And again, my name is Eston Rye, and this has been Hacking in My Lab.